Hey everyone, it's time for section 2, properties of real numbers. This is going to be a short, quick lesson, so just hang in there. Let's go over our objectives really quick. So first we're going to graph and order real numbers on a number line, and then we're going to identify properties of real numbers. So let's start with what are real numbers. This is going to be your vocab for today, so pause as you need. First, a rational number is a number that you can write in the form of a fraction. So anything that you can write something over something else. So if you have decimals that end or if you have decimals that repeat, those are all rational numbers because they can be written as a fraction. Next we have natural numbers. These are our counting numbers, 1, 2, 3, 4, etc. After that we have whole numbers. Whole numbers are natural numbers that include 0. And then integers are positive and negative whole numbers. And then besides that, we have what are called irrational numbers. These are numbers that cannot be written as a fraction. Can you think of any irrational numbers that we might use?
Yes.
Okay, a good example would be this one. Anybody seen that before?
Yes.
That's pi. Okay, we also have, this year we're going to use e, which is instead of 3.14, it's 1.72, so that's e. How many of you like pictures and diagrams to help you understand things? Me too. So I'm going to go ahead and I'm going to give you a little drawing to help you understand and see where you can put real numbers. So inside this category of real numbers, we have those numbers that are rational and those numbers that are irrational. Alright. So the irrational numbers, remember, are like pi, e, square root of 2, anything like that. Inside the rational numbers, a subset of rational numbers would be our integers. Those are positive and negative whole numbers. Inside integers, we have whole numbers. And then inside whole numbers, we have our natural numbers. Those are our counting numbers. So don't forget, rational, anything we can write in a fraction. That's supposed to be an A. A over B. Integers are positive and negative whole numbers. Whole numbers are 0 through infinity as long as they are whole. And then natural numbers are counting numbers, 1, 2, 3, etc. Hope that makes sense to you, or it's at least clearer than mud. Alright, so we're going to start classifying a variable. So, your school is sponsoring a charity race. Which set of numbers does not contain the number of people, P, who participate in the race? I want you to go ahead and pause for a second and think if you can, see if you can think through this.
Okay.
Alright, so our natural numbers are our counting numbers, correct? So, if we counted the number of people, we'd be able to see how many people are there. Let me say, for example, we have 50 people. Would natural numbers be in that set, or would 50 be in that set of natural numbers? Yes, it would. Okay, what about integers? Integers are positive and negative whole numbers. Would 50 be in that set? Yes, it would. What about rational numbers? Anything that's written as a fraction is a rational number. Can 50 be written as a fraction? Sure, we can write anything over 1, right? Okay. Would it be an irrational number? Can we have an irrational number of people going to a race? I don't think so. So I would put D as the answer, and I hope you did too. Alright, so if each person that went to the charity donated $15.50, which subset of real numbers, these same options from above, best describes the amount of money that's raised? Go ahead and pause, think for a second, write down what you think the answer might be. Alright, so we have natural numbers. I'm just going to go ahead and use this from above. Would the donation amount be within the natural numbers? Well, if we had an even number of people that donated, we would have a perfect even number. So yes, it would then. But what if we had an odd number of people that donated? What if we had just one person that donated? They had $15.50. Is 50 cents? It's the same as 1/2. Do we have fractions in natural numbers? We don't. So I would not use natural numbers. What about integers? Same rules apply. No. Rational numbers, I already said that it can be written as a fraction, so that's a possibility. What about irrational numbers? Can you have an irrational amount of money? Not unless you have an obscene amount. Ha ha ha. That's okay, you don't have to laugh. So, rational numbers would be the best answer. Alright, so graphing. We're going to put numbers on a number line. Hope everyone remembers how to do that. This is the easy one. So here, let me make a number line. That's -1, -2, -3, -4. 1, 2, 3, 4. Okay, -5/2 is equivalent to what? Do you remember how to turn improper fractions into mixed numbers? The correct answer would be -2.5. So where would we put that on the number line? Halfway between -2 and -3, right? So this is -5/2. What about the square root of 2? Square root of 2, you're going to have to find an approximation for. Did you find an approximation? So an approximation of the square root of 2 is 1.41. So we're going to go between 1 and 2, almost halfway. This is kind of hard to do with this. Okay, so there's the square root of 2. What about 2.6 repeating? Well, as you might have guessed, it's about a little more than halfway between 2 and 3. So there's 2.6 repeating. Okay, try this one. Square root of 3, -1.4 repeating, and 1/3. Let's go ahead and use the same number line. 0, -1, -2, -3, -4, 1, 2, 3, 4. Okay? Did you find an approximation for the square root of 3? Because that's probably where we should start. So, the square root of 3 is about 1.7. So I'm going to put it right here. Square root of 3. -1.4 repeating is a little less than halfway between -1 and -2. And then 1/3 is between 0 and 1. If we cut this into 3 sections, it would be right here on that first section. 1/3. Got it? Good. Alright, so comparing real numbers, do you remember that less than, greater than sign? Did everybody do the alligator teeth thing? I think we talked about this last year. So this one is the less than, this one is the greater than. Remember, the alligator always wants to eat the bigger one, because who doesn't want the bigger thing to eat? I always do. Alright, so let's take an approximation. The square root of 17 is close to what perfect square? How about the square root of 16? What's the square root of 16? 4. How do 4 and 3.8 compare? Well, 4 is obviously greater than 3.8. So then can we rightfully assume that the square root of 17 is greater than 3.8? I would think so, since it's even larger. Okay, also for this one, square root of 26 is close to what perfect square? Square root of 25. Square root of 25 is 6.25, so obviously the square root of 26 is less than 6.25. Alright, so here's your lesson check. I want some really interesting answers for this one, please. So write an example from everyday life that uses each of the following. So give me an example of something that uses whole numbers, something uses integers, something uses rational numbers. Don't worry about this number 4. I'll take it off. Okay, so I want 3 really good examples, and I want you to share them with your classmate tomorrow. And your homework is Lesson 1-2 on Math Excel. See you tomorrow.